Hello, in this lesson we will discuss logarithmic functions and their graphs. We will learn what logarithmic functions are, how they relate to exponential functions, and how to graph and transform them. Let's get started. In this section, we will learn how to recognize and evaluate logarithmic functions with base A. We will also graph logarithmic functions. Next, we will recognize, evaluate, and graph natural logarithmic functions. And finally, we will use logarithmic functions to model and solve real-life problems. We learned that a function f has an inverse if and only if it is 1 to 1. In this section on exponential functions and their graphs, we found that the function f of x equal to a to the x is a 1-to-1 function, so it must have an inverse. That inverse is known as a logarithmic function with base a, and it is denoted by the symbol log a x, which is read log base a of x. For x greater than 0, a greater than 0, and a not equal to 1, y equal to log base a of x, if and only if x is equal to a to the power y. The function f of x is equal to log base a of x is called the logarithmic function with base a. So a logarithmic function is the inverse of an exponential function. Notice the conversion between logarithmic and exponential forms. Log of base b of x is equal to y is equivalent to b to the power y is equal to x. You are essentially asking yourself, what power do I raise b in order to get x? Now let's look at some examples. Log base 2 of 8 is equal to 3 because 2 to the power 3 is equal to 8. Log base 2 of 32 is equal to 5 because 2 to the power 5 is equal to 32. And log base 3 of 1 is equal to 0 because 3 to the 0 is equal to 1. Now let's look at some important properties of logarithms. The first property, log of base a of 1 is equal to 0 because a to the 0 is equal to 1. Property 2 is log of base a of a is equal to 1 because a to the power 1 is equal to a. Property 3 gives us the inverse properties. Log of base a of a to the x is equal to x, and a to the power log of base a to the x is equal to x. Property 4 is the 1-to-1 property. That is, if log of base a of x is equal to log of base a of y, then x equals to y. For x greater than 0 and y greater than 0. Property 5 is the quotient property. Log of base a of x plus log of base a of y is equal to log of base a of x times y. And property 7 is the power property. Log of base a of b to the power c is equal to c times log of base a of b. These properties are very important because they help simplify logarithmic expressions and they help us solve logarithmic equations. The graph of f of x is equal to log of base a of x is the inverse of an exponential function. Notice that the domain is x bigger than 0 and the range is all real numbers. For growth versus decay, if b is greater than 1, the logarithmic function is increasing. If b is between 0 and 1, the logarithmic function is decreasing. On the graph, notice that f of x is equal to 2 to the power x and f of x is equal to log base 2 of x are inverses of each other. Their graphs are reflections of each other over the line y equals x. Also notice the important points. The exponential function passes through the point 0, 1, and the logarithmic function passes through the point 1, 0. Now we look at vertical shifts of logarithmic functions. On the left, we compare f of x is equal to log of x with g of x is equal to 1 plus log of x. When you add c to the function, the graph shifts up c units. Notice that the point 1, 0 moves up to 1, 1. On the right, we compare f of x is equal to log of x with g of x is equal to log of x minus 2. When you subtract c from the function, the graph shifts down c units. Notice that the point 1, 0 moves down to 1, negative 2. Now let's look at horizontal shifts of logarithmic functions. On the left, we compare f of x is equal to log of x with g of x is equal to log of x plus 2. Adding c inside the function shifts the graph left c units. Notice that the point 1, 0 shifts left to negative 1, 0. On the right, we compare f of x is equal to log of x with g of x is equal to log of x minus 1. Subtracting c inside the function shifts the graph right c units. Notice that the point 1, 0 shifts right to 2, 0. As we learned before, the natural exponential function f of x is equal to e to the power x is a one-to-one function, so it must have an inverse. The inverse of this function is called the natural logarithmic function and is denoted by the special symbol ln x. This is read as the natural log of x or ln of x. So the function f of x is equal to log base e to the x. Log base e of x is equal to ln of x. For x bigger than 0, this is called the natural logarithmic function. The equations y is equal to ln of x and x equal e to the power y are equivalent. Notice that natural log of x is written without a base. The base is understood to be e. So ln of x means the same thing as log base e of x. Since e to the power x and ln of x are inverses of each other, they undo each other. E raised to the power natural log of x is equal to x, and the natural log of e to the power x is equal to x. Their graphs are reflections of each other over the line y equals x. Notice on the graph that g of x equal to e to the power x passes through the point 0, 1, while f of x is equal to natural log of x passes through the point 1, 0. And this concludes our lesson on logarithmic functions and their graphs.